Good morning. Let us study today types of molecules based on rotational behavior or principal moments of inertia IA, IB, IC. For every molecule there will be rotation. So depending upon the shape, it will have different rotational or it will have different principal moments of inertia. Okay. Let us consider a three-dimensional body object. Let us consider a three-dimensional object. It consists of center of gravity through which there are three rotational components. There are three rotational components. The three-dimensional object can be rotated along the x-axis, it can be rotated along the y-axis, or it can be rotated along z-axis. For each rotation, there will be principal moments of inertia. For each rotation, there will be moments of inertia. For example, IA is the principal moment of inertia along x-axis, IB along y-axis, and IC along z-axis. Similarly, for a molecule, let us consider a diatomic molecule. This is the center of gravity through which there are three principal components, rotational components. Therefore, there are three principal moments of inertia, IA, IB, IC. Based on the values, based on the rotational constants or based on the principal moments of inertia, the molecules are classified into four types: linear molecules, symmetric tops, and spherical tops and asymmetric tops. Let us first study linear molecules. What are linear molecules? In linear molecules, the atoms are arranged in a straight line. See, in linear molecules, the atoms are arranged in straight line. In linear molecule, there are three types of rotation. That is, rotation about the bond axis. Number one, the rotation occurs about the bond axis called IA. It gives the moment of inertia IA. Similarly, there is end over end rotation. See, this end over end rotation. This is one end over end rotation. End over end rotation in plane, okay, in plane of the paper. And it gives IB, the moment of inertia, principal moment of inertia IB. Similarly, there is end over end rotation out of plane or perpendicular to the plane of the paper. See, this is plane, therefore this rotation is perpendicular. It occurs perpendicular to the plane of the paper. It gives the moment of inertia IC. Now let us see the values. For rotation along the axis, IA equal to 0 because there is negligible rotation energy involved. Whereas the n over n are equal, IB equal to IC. Okay. Let us see symmetric tops. For example, let us consider the methyl fluoride molecule. It is a tetrahedral molecule. Okay. Similar to linear molecule, there is a center of gravity here. So there will be rotation. There occurs a rotation about the CF bond axis. Okay. It looks like a top. So it is called as symmetric top. Okay. Therefore, IA in this case, unlike a linear molecule, this IA is not equal to 0 because of the methyl group. IA not equal to 0. Okay. It involves appreciable rotational energy. It requires appreciable rotational energy, and similarly, n over n rotation in plane and out of plane will give IB equal to IC, not equal to IA. In symmetric top, there are further two types, prolate and oblate. Let us see first prolate. In prolate molecule, north pole, this is south pole. Therefore, polar diameter, this is equatorial diameter. In prolate molecule, the polar diameter is greater than equatorial diameter. This equatorial, for example, polar diameter is this much and equatorial diameter. Okay. Therefore, this is longer. Rotational constant A is greater, whereas B equal to C. Rotational constant A is greater than B and C because of it is elongated. These elongated sphere. Okay. For example, CH3 methyl fluoride. The rotational constants A equal to H by pi square Ia. We have already studied in rotational digit rotator, rotational spectroscopy. Please watch that. B equal to, therefore A is inversely proportional to Ia. B is inversely proportional to IB. Therefore, it will be opposite. It will be reverse. Ia is greater now. Ia is less than IB equal to IC. Okay. So let us consider oblate. In oblate molecule. In the case of oblate, the polar diameter, you see the polar diameter, this is flattened, this is compressed. Therefore, this is like pumpkin pressed. Therefore, the polar diameter is less than equatorial diameter. See, the equatorial diameter is longer. Now, the polar diameter is less than equatorial diameter. Therefore, the rotational constant B equal to C greater than A. Therefore, since A and Ia are inversely related, this will be opposite. Ia greater than IB equal to IC. For example, boron trifluoride is an example of oblate molecule where Ia equal to 2IB. Okay, that is IB equal to Ia by 2. IB equal to Ia by 2 or IC equal to Ia by 2. IB equal to IC. Now let us see spherical tops. When the rotational constants are equal, then the principal moments of inertia are also equal. Ia equal to IB equal to IC. The molecules are called spherical tops. You see, the polar diameter is equal to equatorial diameter. In spherical tops, the polar diameter is equal to equatorial diameter. Therefore, the rotational constants are equal and hence the principal moments of inertia are also equal. In the case of spherical top molecules, the dipole moment is equal to 0. For example, methane, the dipole moment equal to 0. Therefore, it is microwave inactive or rotational spectroscopy inactive. Although there are rotations along x-axis, y-axis, z-axis through center of gravity, the rotation does not produce any dipole moment. Rotation does not produce or cause dipole moment. Therefore, spherical tops are microwave inactive. Okay, now asymmetric top, the fourth type is called asymmetric top. When it is just opposite, when the rotational constants are not equal in a molecule, rotational constant Ia not, therefore the principal moments of inertia are also not equal, Ia not equal to IB not equal to IC. Then the molecules are called asymmetric tops. For example, water molecule and vinyl chloride and other asymmetric molecules are examples of asymmetric tops where the rotational constants are not equal. Okay, so please, they will in IIT JAM, PG entrance, they will ask questions based on this. Please understand and study well. Thank you for watching.